All right, guys. So first thing we should do is probably graph this. Now, in order to graph this, I think it's important to understand what the parent function of this looks like. So, what would the parent function be? Well, what is the parent equation here?
Log x.
Log, well, I don't know why it's log base 2 of x. That's our parent function.
But there's no 2 on this.
Right, that's why I'm saying this. The 2 is not a transformation. The base is not a transformation. So log base 10 of x is a parent function of base 10. Log base 2 of x is a parent function. Log base 3 of x is a parent function. Log base 4 of x is a parent function. The base does not determine a transformation. So the parent function of this has the same base of 2. Okay. So now, what is the defining characteristic of this parent function? Oh, you can barely see it. When you think about a log and its graph, what does the graph have every time? An asymptote. Where is the asymptote here?
2.
No.
0.
0. Is it vertical or horizontal? It is vertical. So we draw a line. Logs always have a vertical asymptote. Exponential have a horizontal. Okay, that's just a rule you have to remember. And the line for this is this one, x equals 0. Now, on the parent function, from the asymptote, your first perfect point is over 1 on the x-axis. So my first perfect point for the parent graph is over 1. Then, the next point after that is determined by your base. So what was our base in this case? 2. So that means from the asymptote, you go over 2 because our base is 2 and you always go up 1. If the base was 5, what would you do? Go over 5 and up 1. If the base was 10, what would you do? Go over 10 and up 1. Okay? So this is our graph. I should maybe have not made that so thick. Okay, whoops. So this is the function log base 2 of x. What changed with the function we are trying to graph? Yes, it went, let's look at it. What does this plus 2 make it do? 2 to the, so it translates left 2. And what does the 3 make it do? Down 3. So, what exactly are we moving left to? The asymptote moves left 2. So here is my new asymptote. And what is the equation for that? Good. Now from our asymptote, where do we go? Yes, from the asymptote you go over 1. But have we moved up or down?
Down.
So you go down 3 and over 1 from the asymptote.
Interesting.
Which one you did first? Like, couldn't you go over 1 and then down?
Then our base tells us what? We go over from the asymptote how much? 2, still on that same level as the down 3. So we go over 2 from the asymptote up 1. And there's my graph of log base 2 x plus 2 minus 3. Any questions on how we graph that? We're going to have more practice graphing today, don't worry. Now, we have to ask ourselves these questions. What was the domain of our graph? What is our lowest x value? X value. Oh, you're right. No, you're right. I just assumed you get it wrong. I'm so sorry.
Wow.
So our lowest x value is -2. Are we touching -2? No, we are not touching -2. So what do I, oh, and then what's the max value? Infinity. So in set notation, what is set? Squiggly. So in set notation, I have a squiggly bracket. X such that x is always what? Greater than, not equal to, I'm not touching -2, that's an asymptote. So it's always greater than -2. What is my range? What is my lowest y value on this graph? -infinity. And what's my max y value? Positive infinity. So what is my range? All real numbers. What was my asymptote again? X equals -2. What was my y-intercept? What's my y-intercept? What's the x value of that y-intercept always? 0, and then the intercept is -2. If it wasn't such a perfect point, what would you do to find the y-intercept? Plug in
Plug in 0?
for x. When you're trying to find the y-intercept and it isn't a perfect point on the graph like this, what you do is you plug in 0 for x. So up here, we will put 0 in for x. And then today we're going to learn more about how you would exactly solve this, okay? To find the y value. Okay. Any other questions? Yes, Stephen. Not quite. You'll have mine today, don't worry. Any other questions? All right.